Hello and welcome to the Wednesday, August 19th, 2026 edition of the SANS Internet Storm Center's Stormcast. My name is Johannes Ulrich, recording today from Jacksonville, Florida. And this episode is brought to you by the SANS.edu Credit Certificate Program in Cyber Defense Operations. Varonis did publish some interesting insight into a Copilot vulnerability that Microsoft patched with its last patch Tuesday. This vulnerability allows for the exfiltration of confidential data, and I think it nicely shows how some of these AI systems are really hard to secure when it comes to access control. So there are a couple of issues here with this vulnerability. First of all, with Microsoft Copilot, you can create a URL that will automatically pre-fill the prompt. And this was basically how the vulnerability was exploited. The user was tricked into clicking on a link, which then basically opened Copilot and pre-filled the prompt. To make things worse, there was also an auto-run parameter, which would execute the prompt before any additional user interaction. And the intent here was really not that bad. They tried to make it easier to integrate Copilot with other systems. Now, the problem is that Copilot has access to data on your system. So Varonis experimented with prompts like, what's my username? What's my password? And what's certain environment variables? And after some trial and error, they got success and were able to actually then incorporate some sensitive data in the prompt. Of course, the last part to the puzzle is how do you actually get the data out? And this is actually, again, very common with AI systems like this, that the AI system has the ability to retrieve data from web pages. Like a common task would be summarize the data that's at this particular URL. So what Varonis did here is that they used the environment variable, for example, that a Copilot retrieved, built a URL including that environment variable, and then asked Copilot to summarize the content from that URL, which means Copilot reached out the URL. That URL is then hosted on the attacker's website. The attacker sees the content of the environment variable as part of the URL, and you have data exfiltration. So I think the two big patterns here is once the data is accessible by the AI, then there is no more real good access control. Like Microsoft tried it. They tried to sort of build some constraints around what prompts you can ask, but there's always a workaround, always a way to ask the question that these safeguards don't work. The second big problem with many of these sort of chatbots and such is essentially server-side request forgery, where you can trick the bot into going out to arbitrary URLs. And if you can manipulate the URL to contain then sensitive content, or maybe you just have it reach out to an internal URL, so for more classic server-side request forgery, well, you have a vulnerability. Microsoft patched this vulnerability by not allowing some of these links as it did before, so essentially breaking some of the integration here, but that's at least the only way how we can make sure that these sort of one-click attacks don't work against these AI assistants. And CISA, the FBI, and the Department of Health and Human Services did publish an updated report on the Medusa ransomware. They first published this report in April, but now updated it with new indicators of compromise and some additional information that they updated. One interesting thing is that initially it was sort of more believed to be sort of a healthcare-focused ransomware, and that's also why Department of Health and Human Services is involved here. But apparently it is more opportunistic and basically takes other victims' money as well. The other thing is that they added some additional indicators of compromise. One that I found interesting is the site oast.site. This is often used by pen testers too, so it's on particular sort of bug bounty hunters and such. it runs a public instance of Interact SH, which is often used to basically detect exploitability. You get ping back if the particular site or the URL that you attempted to access on that site was actually hit. So it's sort of a common site used in proof of concepts. Definitely something that you want to keep an eye on. I see this in a lot of malware and such also being used in a lot of sort of bots that we see sort of going around trying to find vulnerable sites. So definitely a domain to keep in your list of suspect domains to watch out for. Well, I just mentioned the first story, how difficult it is to implement access control in AI models. Well, Google may have an interesting answer here. They call it HEIR, HEIR. It's for homomorphic encryption intermediary representation. Homomorphic encryption is not really used that much these days, but really here in AI, there's a nice use case for it. The idea behind homomorphic encryption is that you're able to actually operate on the data without decrypting it. So you can basically build models and everything without having to decrypt the data. Would be interesting to see what the computational overhead and such is of this particular algorithm, but they open sourced it, so it's free for anybody to use. And it appears Geekom, a company that's famous for its micro PCs, did distribute malware on one of its support websites. The malware came in the form of a network driver. Now, there is a little bit dispute here between the website videocards.com. I'll link to that because they have, I think, a good sort of summary of what may have happened here. But Geekom, on the other hand, disputed some of the details here. It's not clear whether or not the network was actually malicious. I haven't seen sort of a malware analysis, but it does trigger several antivirus tools. So it's highly likely that this network driver is malicious. Now, Geekom's response in part did not actually dispute the maliciousness of the driver. They just said that this particular driver was no longer really active, was no longer current, and the website or the page it was hosted on wasn't really supposed to be live anymore. So it was just a legacy page they forgot to remove. It would still be a problem if back in the day they distributed a vulnerable driver. Apparently, this particular driver, the hash, was around, according to Virus Total Records, since 2024. It did not ship with current systems. So if you have a Geekom system and you hadn't changed the drivers it came with, you shouldn't have a problem with it. Also, of course, only affects the Windows versions. If you're running Windows on these systems, I know a lot of people sort of buy them as a little sort of Linux boxes as well. So double check that you don't run it. And if you are seeing the alert from antivirus, and apparently Microsoft does flag this particular driver as malicious, then head to the link and check on Geekom sites. They have a little bit tips in how to then remove this particular driver. Well, and that's it for today. So thanks for listening. Thanks for liking. Thanks for recommending this podcast, and talk to you again tomorrow. Bye.